This is a projectile motion simulation in Java using 4 balls, each with its own speed, mass, size, and launch angle. The program visually demonstrates how objects move under the influence of gravity, creating realistic parabolic paths. Projectile motion has fascinated scientists and engineers for centuries. In the 1600s, Galileo Galilei studied how objects like cannonballs and spears move when launched at an angle. He discovered that horizontal motion and vertical motion are independent, meaning an object's forward speed doesn't affect how fast it falls. Later, Apple guy Isaac Newton formalized the laws of motion and gravity, explaining why objects accelerate downward while moving forward, and how forces govern paths. Leonhard Euler and other mathematicians later redefined the equations to predict motion more precisely, which led to modern physics and engineering applications. For this simulation, I use many physics equations. However, first I solved for the velocity component. Solving for the velocity components, I did Vx is equal to V times cosine theta and Vy is equal to V times sine theta. Solving for Vx, I did 9 times cosine 45 degrees, and solving for Vy, I did 9 times sine 45 degrees. Vx turned out to be 6.36 meters per second, and Vy also turned out to be 6.36 meters per second. Next, I solved for the time of flight. Using the time formula, I did t is equal to 2 times 6.36 all over 9.8, which then led me to getting 12.72 all over 9.8. And then solving that, I got the answer to be 1.3 seconds as my time. Next, I solved for the maximum height. Using the maximum height formula, I did h is equal to 6.36 squared all over 2 times 9.8. Solving for h, I get 40.45 all over 19.6. And then solving for h, I got the final answer to be 2.06 meters, representing the maximum height. Next, I solve for range, which also represents our horizontal distance. Using the formula r is equal to vx times t, r is equal to 6.36 times 1.3, which gives me the final answer of r to be 8.27 meters, which represents our horizontal distance. Next, I solve for the vertical velocity after 1 second. Using the formula Vy is equal to Vy naught minus gt, I did Vy is equal to 6.36 minus 9.8 times 1, which is 1 second. And then I got the answer to be Vy is equal to negative 3.44 meters per second, representing the vertical velocity after 1 second. Next, I solve for the resultant velocity at launch. Using the formula v is equal to the square root of vx squared plus vy squared, I did v is equal to the square root of 6.36 squared plus 6.36 squared. Then I got v to be the square root of 40.45 plus 40.45. Then v was equal to the square root of 80.90. Then, doing that square root value, I got v to be 8.99 meters per second, which is about 9 meters per second. So the resultant velocity at launch is about 9 meters per second. Lastly, I solve for the launch angle using the formula theta is equal to the tan inverse of Vy all over Vx. Theta is equal to the tan inverse of 6.36 all over 6.36, which just cancels out to be 1 over 1. So therefore theta is equal to the tan inverse of 1, so theta is just equal to 45 degrees, representing the launch angle for the simulation. Now I will be going through how I coded the simulation. I started by using Java Swing to create a window with a JFrame and a JPanel, setting the layout to null so I could manually control the position of each ball. Then I loaded images using ImageIcon, scaled them to different sizes, and placed them on the screen using JLabel with specific starting coordinates. Next, I defined variables for angles, velocities, and gravity, and converted each launch angle from degrees to radians to calculate the horizontal and vertical velocity components using sine and cosine. After setting the initial positions, I used a timer that runs every 10 milliseconds to continuously update each ball position by adding the horizontal velocity to the x value and subtracting the vertical velocity from the y value, while also reducing the vertical velocity over time to simulate gravity. Finally, I added ground checks for each ball so that once they reached a certain y value, their velocities are set to 0, stopping their motion and completing the simulation. Next, I wanted to experiment with the different velocities and launch angles within this simulation, and here are the test trials that I got. In conclusion, this is a simulation of projectile motion in Java. I hope you found this video helpful. The source code will be posted in my GitHub attached to my channel description. Please make sure to subscribe if you want to see more coding videos. The next project I will be making is a gravity simulation with a ball. So I hope to see you guys all then. Bye bye and stay safe.